Okay. Use the nth term test, which is the test you should use at the beginning of every single series question. Just check that first. But here it's telling us outright to use it. Nth term test for divergence. To show that the series is divergent. Or state that the test is inconclusive. Okay. So basically just use the nth term test on this guy. See if it works, great. If it doesn't, just say so. That's all you have to do. Right, so the nth term test is literally just take this limit of the sequence a sub n. So you take the limit as n approaches infinity of n over n plus 6, which will end up being 1. So since the limit of a sub n is not equal to 0, then the series of a sub n diverges. So that's what you'd have to say on the test. Any questions on number 9? Okay. Number 10 says use the integral test to determine whether the series converges or diverges. Okay. So the integral test basically says do a integral and change it to x. So you're going to go from 1 to b of 1 over 2x minus 1 dx. Since it told us to use integral tests, and we don't have to check those two cases whether or not we're allowed to because they told us to, right? So if they did not tell us, then you would have to check if it's increasing and check if it's continuous. And if it is, great. And it is. But let's just go ahead and do this. Let's do the simple substitution. So let u equal 2x minus 1. Du would be 2 dx. Du over 2 will replace my dx. D over 2 over u, which is equal to the limit as b approaches infinity. Just pull out the 1/2. Integral of 1 over u du is equal to the limit as b approaches infinity of 1/2 ln, and then replace the u will be right here, right? From 1 to b, which would give us the limit of 1/2 times ln of 2b minus 1 minus ln of 2 times 1 minus 1, which this one will be 0, right? 2 minus 1 is 1, ln of 1, this goes to 0. But this isn't going to be infinite, so this will be infinite. And when that happens, well, we do not have an area, right? If we don't have an area, this diverges by the integral test. Are there any questions on number 10? Okay. The next one is the same thing, use an integral test. So we'll skip 11. The answer is diverges for 11, but you have to show your work, of course. 12 moves on to the ratio test. So this one tells you up front, use the ratio test. To determine if the series converges or diverges. So here's a series from 1 to infinity of n factorial times e to the negative 7n. Okay. So a sub n is, of course, what you're given, the sequence part. A sub n plus 1 is equal to n plus 1 factorial e to the negative 7 times n plus 1, which would be e to the negative 7n minus 7. Yeah. So the ratio test is the limit as n approaches infinity of the absolute value of an plus 1 over an, which is equal to the limit as n approaches infinity of n plus 1 factorial e to the negative 7n minus 7. Divided by n factorial e to the negative 7n. Let's expand the factorial. So that would be n plus 1, expand it one term, and then stop at the n factorial. So it's always 1 minus each term. E to the negative 7n can be separated like this, right? We're all decent at algebra, I hope. So now we can cancel the e's, the factorial. So now we have the limit as n approaches infinity of n plus 1 times e to the negative 7 over 1, I guess. Looks like this is infinite, right? Because this number is not going to do anything here. I'm sorry. E negative 7 does nothing. The n is on top and goes to infinity, so the whole thing goes to infinity. And there's 3 rules for the ratio test. It says if the limit is infinite or greater than 1, then the series diverges. So since this would be the conclusion, since the limit of an plus 1 over an is greater than 1, then the series a sub n diverges. I don't need that as the values, actually. This is our ratio test conclusion. So 13 and 14 are also ratio tests with factorials, so it'll be the same thing. Okay. Let's do a root test. So this is 13, 14, number 15. All right, use the root test to determine if the series converges or diverges. Ln of n over 9n plus 1 to the n. So this is a dead giveaway that we should use a root test, but they told us, so cool. The requirements for convergence is the same as the ratio. So the limit, let's write down what an is first. It's a good habit to do. Ln of n over 9n plus 1 to the n. So the limit of the nth root as n approaches infinity of ln n over 9n plus 1. So that's absolute value, by the way. Sorry, it's a little messy. Okay, so the roots will cancel. Let me rewrite that. That looks crappy. Bothers me. absolute value of a sub n of 1 over n, which would be the limit. I'll just go and put it down here. Of the absolute value of ln of n over 9n plus 1 to the n 1 over n. Okay. So these cancel. The 9n plus 1 will grow much faster than the logarithm, so the limit will be equal to 0 because the n's are gone. So since the limit of the nth root of a sub n is less than 1, then the series a sub n converges. That would be your conclusion. Is there any questions on this problem? Okay, so the one after that is also the root for number 16. "17 doesn't tell you what test to use. It just says to do it. Okay. Determine convergence or divergence. Pretty much every single question in chapter 9, I think. All right, so this question, so it doesn't tell you what test to use. So on your exam, if it doesn't tell you, you need to figure it out, right? The first thing you should do is use the nth term test, right? So step 1 is identify the sequence and then take the limit of the sequence and determine if that limit is 0. So nth term test, right? Take the limit as n approaches infinity of a sub n, which is equal to the limit as n goes to infinity of 6n squared plus 2 over n cubed plus 6n plus 7. So the degree down here is bigger, so the limit will go to 0, which means divergent test tells us nothing. But at least we know that we have to do something else. Now, looking at this, I would probably do, I think the comparison test would be the easiest route. but you need to choose a Bn. If you're at a loss and you look at this, and I don't know what the hell what test to use, integral test would technically work, right? Because you can see, um, well, yeah, it would, because you have u and du, so you could do a u sub, integrate this guy, and determine if it diverges or converges. But integral test is usually, I usually recommend that as a last resort, because it's not always the easiest, and sometimes the integrals can be a pain. But this integral wouldn't be hard. But let's go ahead and practice the direct comparison. So I see n squared, n cubed. So I'm going to choose, so an is this. Excuse me. Bn will be, so I'm going to choose the highest degree in the top, highest degree in the bottom, which would reduce to 1 over n. So I'm going to compare this guy to this one, right? This one is, let's see, can I determine which one's bigger right away? Don't think I can. But we can do a limit comparison and hope that does something for us. Yeah, let's try that. So let's see what happens when you do the limit of an over bn as n goes to infinity. So the limit would be this guy first. And hopefully we get something that's not equal to, I think if it's equal to 1, we basically know nothing. Times dividing by this guy, so we would get n. Yeah, okay. So then the limit as n goes to infinity, limit as n goes to infinity of 6n cubed plus 2n over n cubed plus 6n plus 7 would equal to 6. So now let's see what the rules are for limit comparison. I believe as long as it's greater than, if it's greater than 1, I believe it's, let me double check. Oh, here it is. So suppose this is an, oh, I see. Yeah, so this test says that if the limit is positive, greater than 0, and is finite, which it is, we got 6, then both series either converge or diverge. This clearly diverges because it's a divergent p series, so that means that this guy also diverges. So since the limit of an over bn is equal to 6, and the series bn diverges, then then the series a sub n also diverges. So this is the limit comparison. I was going to do direct, but I didn't work out the way I wanted it. I think if it's equal to 0 or negative, I think for limit comparison, it doesn't tell us anything. But it should be in your notes what I gave you for limit. Okay. So that was at 17. So the last few are about what's it called? Radius of convergence, and then the power. So power series, and then the Taylor and Maclaurin. You guys have any questions on 17? Number 18. Find the series radius of convergence. Okay, let me find the series. Okay, so remember we said when we did the power series, you're basically going to do, what's it called? Either ratio or root test. That's going to create the radius for you because it has that restriction where it will only converge if it's less than 1. And then you solve that inequality, which creates the interval of convergence. And then when you have that, you can find the radius just by looking at it. So my a sub n is this whole weird thing, the sequence. So we're going to use the root test because I see a power of n. Yeah, should be fine. Let me double check though. Actually, yeah, it's okay. It's interesting. So the limit of the nth root of a sub n, absolute value, is equal to the limit as n approaches infinity of the nth root of the absolute value of x minus 1 to the n over 2n plus 5. So these cancel. Leaving me with the limit as n approaches infinity of the absolute value of x minus 1 over 2n plus 5 to the 1 over n. So when this goes to infinity, this will zero out, which means this will turn into a 1. So this becomes x minus 1 over 1. And that must be less than 1. So solve that inequality by removing that. No more inequality, sorry. Solve for x. So the interval becomes add 1 over, add 1 over. So the center is 1. So the distance, the radius would be 1. It would be from the center, so it'd be 1. So this is the interval of convergence. We did not test the endpoints, but since it only asked for the radius, then we don't have to. Radius of convergence is 1. This is the work I want to see to determine why it's 1. Okay. Is there any questions as to how we got there for the power series? All right, let's move on to 20, where they actually make us do the interval of convergence, where we have to, oh man, I forgot a page there, where we have to test the endpoints. Find the interval of convergence of the series. Again, these are all power series at this point. All right, so I see powers of n, which means I should probably do a root test. So a sub n, x minus 2 to the n, over n to the 4, 2 to the n. So start the root test. So the limit as n goes to infinity of the nth root of a sub n, which is equal to the limit as n goes to infinity of the nth root of the absolute value of x minus 2 to the n over n to the 4th times 2 to the n. So the nth root is going to cancel this n and that n, but this will just have we'll just deal with the 4. So we'll have the limit as n approaches infinity of the absolute value of x minus 2, so that one's canceled, n to the 4 over n times 2. So the 2 to the n, these will be canceled out. Over here, it'll just be underneath because it's not going to cancel, right? So take the limit, and this will go to 0, which means this goes to 1. So yeah, that's 1, 2, okay. So the limit ends up giving us x minus 2 over 2. And that must be less than 1 for convergence. So solve for x. So we get, remove the absolute values. It gets us to here. Multiply everything by 2. That gives us this here, add 2 over, and you get 0 less than x minus 2 less than 4. So this is the interval of convergence, right? So it'll be, we just need to test, do the endpoints work? Okay. And it looks like, yeah. So this is going to be the interval. But the way you would test would be like this. So the series of 0 minus 2 to the n over n to the 4th 2 to the n, right? Sorry. Which would become this. That's a negative 1 to the n times 2 to the n over n to the 4, 2 to the n. So these will cancel. This alternating part won't matter, so I'll take an absolute value. This p is 4, so this becomes a convergent p series. So you take an absolute value. And find a convergent p series. So you'll have absolute convergence at 0. That's why I'm including it. Then you'll do something similar. I'm going to skip the test just to save space here. Let x equal to 4. So then you'll end up with this guy. Of 4 minus 2 to the n over n to the 4th 2 to the n, which ends up being n equals 0 to infinity. So that's going to be a 2n over n4 2n. So these cancel, and there you're left with, so this is a convergent p series. Right here. So that's why I included both of them, because I could tell it's going to converge at the endpoints. So the interval will be written this way, or brackets. That's my interval of convergence. Okay. So you'll do the same thing whenever you say whenever you say the word interval or find the interval. You do the same thing we did for the radius. It's just that the one extra step is test the endpoints by plugging in x equal to 0 and x equal to that 4. That's it. Okay, let's move on to the Taylor series. This is Maclaurin, so this is going to be number, what number are we on? 20, 21, 2, 23. So 23 is a Maclaurin series, so similar to the ones we did before. So we're going to expand or find the series representation of e to the negative 6x. So I already forgot what number we're on. Shit. 1, 20, 1, 2, 3, 23. Find the Maclaurin series for the given function, e to the negative 6x. So remember we said what you got to do is take a bunch of derivatives, right? So first, it's just itself. First derivative. Yeah, it's fine. I'll just make it. So number 1 would be negative 6 e to the negative 6x, right? Second derivative, you'll see that it becomes positive 6 squared, right? Triple derivative goes back to negative, so that's negative 6 cubed. Okay, and this is Maclaurin, which means you got to plug in the 0 for each one. So that'll be 1, negative 6, 36, what's 6 cubed? I forgot. 216 negative. Or just keep it in power form, I guess. Let me pull out my formula because I don't recall. Okay, here we go. All right, so the formula is n equals 0 to infinity of f to the nth derivative at c times x minus c to the n over n factorial. So for us, we're going to have first zeroth derivative, right, as the first term. So that'll be 1 times x minus 0, because 0 is c, because this is a Maclaurin, right, to the 0 power over 0 factorial, minus 6 times x minus 0 to the first over 1 factorial plus 6 squared times x minus 0 squared over 2 factorial. So I think I see the pattern here. So the answer based on that pattern will be 6 to the n. Well, actually, let's deal with that negative first, the alternating piece. Alternating happens every odd, right? At the 0th and at the first term, yeah, so negative 1 to the n should cover me, right? Times x, oops, forgot my 6. Times 6 to the n. So 0, 1, 2, 3. Yeah, I got that one now. X to the n. 0, 1, 2. Yeah, we're good. Over n factorial. So that should be the answer. Let's find out. Yeah, it looks like Negative 1 to the n, 6n. Yeah, cool. Any questions on Maclaurin and Taylor? And that's the procedure. You take derivatives, plug in the c. If they say Maclaurin, then they're implying that c is 0. Otherwise, they have to tell you what c is. You plug it in and you get this first pattern, and you plug that into this formula. The formula will then help you develop the formula, your own formula for the power series representation for e to the negative 6x, which is pretty cool. You guys have any homework questions that you're struggling with?
Yes, sir. I actually had two. Could you do
Yeah.
number 12 on 9.8?
12 on 9, 8. Let's see here. Give me a sec. Okay, 9.8. Number 12. Okay. Okay. So that bottom part, all that is telling you is here. Let me show you. We'll do it right now. But did this 135 confuse you?
Yeah.
Yeah, it's actually as doesn't matter. You can just put 2m minus 1. That's the same thing.
Oh, okay.
You can just disregard this because that's what
Cause,
this means.
cause won't that cancel out too?
Yeah, because 2n minus 1 is all the odd numbers, right?
Oh, yeah, yeah. I see what you're saying. Okay.
So this is basically saying that if I have all the odd numbers on the bottom, all the way till 2n minus 1, which basically can be represented by 2n minus 1, you just use that instead. I don't know why they wrote it this way. I think it's a little confusing, but basically they're trying to say, make sure there's nothing but odd numbers down here before you start. In other words, use 2n minus 1.
All right, I got it.
Did you want to do it, or do you see how to do it?
Um, so I got for my when I did the limit, I got the limit from n to infinity of n plus 1 times 2n minus 1 times x plus 4 over 2n plus 1. And I wasn't sure how that, like what that equaled.
Which test did you? I'm assuming you did the ratio.
Yeah, I did the ratio.
Yeah, let's go ahead and do it. We'll use the ratio, and you have a 4 instead of a 2. Is that the difference?
Oh, yeah, yeah. I have a 4.
Okay, we can put a 4 in there. Okay, let me just write this down. So yeah, I just use this guy down here. So my a sub n is this guy here. Let me switch over. Am plus 1 will be this guy. And if I do 2n plus 1 minus 1, that would turn into 2n plus 1. So I have a 2n plus 1 down here. Okay. All right, so the limit of the absolute value of an plus 1 over an as n goes to infinity would equal the limit of, let's see, this goes first. Times, so I'm going to go ahead and skip a step. An's on the bottom. I would flip and multiply this fraction. So that would be 2n minus 1 over n factorial x plus 4 to the n. Okay, so let's expand the factorial. So that'll be n plus 1 times n factorial. Separate the x plus 4 times n times x plus 4 for the first one over 2n plus 1 times 2n minus 1 over n factorial times x plus 4 to the n. So these would cancel. Factorials would be gone, leaving me with a limit as n approaches infinity of n plus 1 times 2n minus 1. I'm going to go ahead and put it together. X plus 4 over 2n plus 1. You can tell that this limit is going to go to infinity, right? Because this is 1 degree bigger than this guy, right?
Yeah, this is where I got stuck.
So this is an infinite limit. But you have an x plus 4 here. So this can dictate what happens to the rest of this nonsense, but only when x is equal to negative 4. So the series a sub n only converges when x equals negative 4. It diverges everywhere else based on the ratio test.
That's weird. I put it's asking for the interval of convergence, and I put -4, and it didn't give me the. It said I got it wrong.
Let me check everything first. Because on mine, it looks like they got. Let me see if I missed something. Huh. Oh, okay. On theirs, they cancel one of the 2n minus ones. I see. So I misunderstood. So everything is right. The only thing is, it looks like that 135 whatever. Looks like they might have used it. Give me a sec. Let me read this. N plus 1. So basically, what they did, it's just a weird question. They went ahead and left this here. And they said, well, this right here will cancel this guy. So basically, they're saying there's two pieces. Yes, this originally, right? I thought they were saying that this is the odd whatever, right? But they're actually saying that we have that odd piece plus everything before it. So this including everything. So then,
Why wouldn't you add that? Oh, okay, so you do add it to the n+1.
yeah, they all have it.
Okay.
So I'm trying to double check here. But then wouldn't there be an extra one? Huh. No, actually, I don't think that's it. I think that's a mistake. That's not it at all. How do they they cancel this somehow? I do not agree as to how they did it just yet. Um, hmm.
Is it because the on 2n-1 and 2n+1 they're both 2n, so you can just cross them out?
Oh, wait a minute. Oh, I'm sorry. Say that one more time.
Is it because so the 2n-1 and the 2n+1 both have 2n, so can you cross those out?
Now we can't cancel the two ends, and they're not the same. Because this guy stays +1.
Oh, okay.
The one
That's
that
weird.
cancels is this one, according to the solution. But they don't explain why in the slightest. There, let me show you. I don't know if I might be missing something. Let me look at this carefully. Can you see the solution?
Yes, sir.
So this is basically what we did. We had the n+1, right? Ours was x+4. n+1 was right there. We separated it, but they had two pieces down here. Or
Yeah, that's weird.
where we do not. And then this is the same thing we had. So this guy flips over, and this cancels this. Yeah, but that doesn't make any sense. Like, where the hell did this come from? I'm sorry, this one. Hmm. is weird. Yeah, I'm just gonna remove that question. It seems like there's something wrong with it.
Okay.
Doesn't make sense. Sorry about that. Do you have any other questions?
Yeah, let me see. Okay, on 9.9, number 2.
9.9. Let's find the power series, right?
Yeah.
Okay, so this one is just going to be some funky algebra, but we can do it. So you got to force it to look like that geometric shape or formula.
Hmm.
Okay. We want it to look like this, right?
Hmm.
So first thing is I need this. Oh, yeah, it said centered. C is -3. Okay. All right. So the center piece is going to go here. So we start by manipulating this guy here into 3 minus x plus 3. So it's minus minus, so it becomes a plus. The next thing is I need to factor a 3 out so I can force this to be a 1. So I factor a 3 out of here, out of the whole bottom part, so I'm going to put a bracket. So this becomes a 1 minus x plus 3 over 3. Because I factored a 3 that wasn't there, so I had to kind of divide it to compensate. Okay, so now I'm almost there. Let's see here. But I can't just add a 3 for no reason. So I missed a step here. I kind of cheated. So if so you agree that this is subtracting a 3, right? Because there's a minus in front.
Yeah.
So if I were to subtract it,
It'd go to 0. That was my problem.
um, I have to balance it because this is not an equation. This is just one thing that I'm working with. So I have to add 3 because I'm subtracting 3. Does that make sense?
Um. Okay. Yeah.
So let's show an extra step here because it's the algebra can get a little weird. So let me write that better. Start over. Okay, so I need to center it. So I need to add 3. But since it's negative, I'm going to subtract 3. So this is what I'm going to do. I'm going to add 3
What would you
minus 3.
do if 3 wasn't negative? Because in mine, it's using different numbers,
Mm-hmm.
and whenever I like add it in, it makes the term that's supposed to be 1. It makes it 0.
If this was a 3, like a positive, is that what you're saying?
Yeah. Yeah.
I would have to do the opposite. So it would be,
X plus 3.
yeah, there'd be a plus 3 here, and then I got to factor a negative, so it would become minus. So let me show you the step. So right now it's 6 minus, factor the minus, you have x plus 3. So at this step, it would be a minus 3. instead of
Um, but wouldn't it cancel? Wouldn't you have to? Wouldn't you subtract 3 if it
well,
was? If you had like +3 for the center, wouldn't you have to subtract 3 from the other side, and then it would make that term 0? Like where you put 3 plus 3, wouldn't you do 3 minus 3?
mm, I see what you're saying now. You're talking about what would happen to this piece.
Because that's what happens in my problem.
If it's minus, let me see here. What numbers? You said yours is number 2?
Yeah, I could give you the. Do you want me to give you the numbers that mine uses?
Yeah, yeah.
So mine's f of x equals 3 over 7 minus x.
3
3
over.
over 7 minus x.
Mhm.
And then it's centered at -7.
Yeah, it'd be the same. It's -7. Yeah, so it'll be the same as what I was doing here. So it'd be -3 -7 +7.
So wouldn't that make it equal 0?
Um, I mean, yeah, but I'm not gonna group them together, right? I'm gonna group these together. I can choose what I want to add, right?
Okay, yeah.
So let's go ahead and do yours. So we got 3 over 7 minus, so minus x. So right here, I need to subtract the 7. So here we go. Plus the 7 because I'm going to do -7 right here, which I then factor. So this is 14 minus x plus 7, right?
Oh, okay, okay. I see what I did.
So then I factor the 14 out of there. So I get 3 over 14 over 1 minus x plus 7 over 2. Now this is all, the minus is on the whole thing.
Mhm.
Okay. So then we're almost there. So the 3/14ths are just kind of in the way. Well, let's see. But we're pretty much there. Let's rewrite this in this form, the a thing. This is 3 over 14 over 1 minus x plus 7 over 2. So the power series would be, or the geometric, well, actually, it'd be a power because we have that x. It's going to be n equal to 0 to infinity. So we went in reverse with our formula. 3/14 times x plus 3 over 2. Double check everything. But factor out of 14, I should have a 14 here, actually, not a 2. I don't know where the hell that came from. Sorry. So this should be 14. To the n. So final form here, it should be 3/14 times x plus 7 to the n over 14 to the n. Yeah. But they want the interval, right? Not just the series.
Yeah.
Okay. So at this point, you do the root test. So an is this guy. Separate the powers just so you can see the root canceling the ends. Not because it's necessary. This is more obvious. So the limit as the nth root of the absolute value of a sub n, as n goes to infinity, is equal to the limit as n goes to infinity of the nth root of 3 over 14 times x plus 7 to the n over 14 to the n. So these n's are canceled. So I have the limit as n goes to infinity. Let's see here. So the 3 will get an n, 1 over n. The 14 will get a 1 over n. And I'll get the absolute value of x plus 7 over 14. So that limit, these will go to 0 and you take the limit. So this must be less than 1. So once you take the limit, these are gone. So all you have left is this guy. Solve for x. Add 7 and you get the interval should be -7 to 21.
Oh, I think you added 7 instead of subtracting it.
Oh, yeah, you're right. Sorry. Thanks. So -7 be 21 and 7. So try that interval out. And
Yeah, that works for me.
cool. Do you have any other questions on chapter 9? All right, guys. Well, I've opened the test up. I'll leave it open until next Thursday. Next Thursday, we'll probably move on to something else. Or sorry, this Thursday we'll move on to something else. I'm not sure yet what we're gonna do just yet, but for now, please focus on finishing chapter 9 homework and getting ready for the exam. Okay. Let me know if you have any issues or if we need more time or something. Okay.
Are our previous test grades in yet?
The last test? No, not yet.
Okay.
I'll do that soon.
Is the final gonna be the lesson 10, or is it gonna be over all the lessons?
I'll let you know Thursday. That's what I need to decide on this Thursday.
Oh, okay.
But yeah, I'll let you know soon. All right, guys. Well, we'll stop here, and I'll see you on Thursday then.